computerized math and history, and we are going to take a look at projectile motion. And sorry about the camera footage because I actually dropped my iPhone in the school cafeteria when I was helping someone out taking out the trash. Well, I'll get a new phone in about a few weeks, but don't worry, this will end. So what we're going to do is learn about projectile motion. And I'll make the characters and the lettering big so you understand what it is. So here's what we're going to do. Solve the problem out. But this is a different type of problem. So a soccer player kicks a soccer ball at a level playing field with an initial velocity of 11.3 meters per second at an angle of 35 degrees above the horizontal line. We have to find out how long was the ball flying in seconds, how far did the soccer ball go, what was the max altitude of the ball, and what was the final velocity when the ball hit the ground. So what we're going to do is find the flight time and the max altitude for part A. We're going to do part B tomorrow. So let's get started on the problem. Before we do that, we have to understand some variables. So when something flies at a parabola-shaped trajectory, here's what happens. We have a level playing field. We go over and back here, and we have two arrows going like this. The two arrows is going to represent your dy, your distance by height. Your velocity is going to represent the speed going through the air, while your dx, your dx is going to represent the distance at ground level, or the distance on the ground. Another thing we have to think about is if we want to calculate the altitude and the velocity of the ball when it flies, the soccer ball, the hypotenuse of a right triangle is going to represent your v, velocity. Your dy represents the height of the triangle. Your angle right here, theta, talks about what angle the soccer player kicked it at. And your dx is going to represent the distance of the ball that travels. So now we understand what we have to do. We have to use those two pictures.
That's a bit short, and the coach doesn't look happy with the technique there.
So what the problem already gives us is we know that our initial velocity is going to be 11.3 meters per second. But also, the angle the soccer player pointed at was the angles of degrees is 35 degrees below, or actually above, the horizontal line. So basically, what we have to do is find out if we measured this as a trajectory, we have to look at it as a right triangle. So we've got to find out what our dy and our dx is, because those two information is going to help us find what the flight time and the max altitude of the object. So here's what we're going to do. How are we going to find the x on x, the information on x and the information on y? So to find the information of x to help you furtherly get the key and find out what the next solution is, you're going to have your velocity of x is going to be your velocity multiplied by the cosine of your theta, or degrees. For your information on y, it's going to be your velocity x is going to equal your velocity times your tangent. Then you have to multiply by your number of degrees, your theta. So what we're trying to say is if we have 11.3 and we have a degrees of 35, what we're going to do is this. The cosine of 35 is going to bring you to 0.819. But when you multiply that by a v, or 11.3 meters per second, you are going to get an answer of 9.25. So your velocity on your x is going to be 9.25. On your y, it's going to be a little bit different. When you find the tangent of 35 degrees, you get around 6.48. So that is going to be 6.48. But you have 6.48 when you do the tangent of theta in degrees, but then you multiply by 11.3. So that is this times that. Well, that and that times 11.3, and that's going to bring it to 6.48. So what we're going to do is use your x, your vx, and your vy. Your vy is going to equal 6.48. So let's get started on the flight time. So how long did the ball stay up in the air? So in order to solve this out, we have to find out what our time is. So we have to do a speed dating problem. So what we're going to say is the initial velocity of y. We're also going to say the final velocity of y. We are also going to say our distance or our displacement in y, our acceleration of y, and our time in seconds of y. We're trying to find the time in seconds of y. So we know that our initial velocity is going to be 6.48 meters per second. We're not going to use 11.3 meters because that is what's helped us find what the values of that triangle is, but also helps us find what that and that is. And since we're trying to look at flight time, we're going to play around with Vy. So Vy is going to be 6.48 meters per second. And we're going to say that our Voy, our final velocity of y, is actually going to be 0. So picture this. Imagine you see this diagram right over here. We realize that this was our v, the height is going to be our dy, and the dx is going to be the distance. What we're trying to calculate right here is the reason why your initial velocity for y is 6.48 and your final velocity for y is 0 is because instead of calculating the whole thing, what we're going to do is calculate this portion of the whole thing. If we find out what half it is, then we can find out what the whole thing of it is. So 0 is going to be on the top because that's when the ball starts to fall, or that's when the ball stops gaining altitude, and that's when it starts to fall. The reason why it's VO initial is because the ball has to go up there and climb. We have no idea of what the height of the max altitude is, but we do know that the gravitational pull is 9.8 meters per second squared. We have no clue what time is. So what we have to do is use a kinematic equation. Which are the three? The first. So we're going to say the final velocity of y is going to equal the initial velocity of y. Then we have to add that by our acceleration of y. Then we have to multiply it by our t of y. So here's what's going to happen. 0, because we know that's final, is going to equal 6.48. And then we have to minus by 9.8 ty, or ay. Ty. We're trying to find what ty is alone. So we get, for over here, we're going to have a positive 9.8 equals 9.8 ty equals 6.48 divided by 9.8 divided by 9.8. And we should get our t is going to be 0.665 seconds. But that is only for half of the portion. So if that is in seconds, and that is that red half of the portion, if the first half was 0.665, then the other one also has to be 0.665. Meaning that when we multiply by 2 the total flight time of the ball is going to be around the same thing, but by 2. When you add these numbers, you're going to get around 1.33 seconds. So that is how much time the ball stayed up in the air. And yes, I did use a calculator on this assignment. So we knew about the flight time, but what happens if we try to find the max altitude of the ball? How far, or how much distance in height did the ball go up before it started to fall down? So if we try to find the max altitude, not only we have to do math, but yes, we have to do that speed dating thing again. So our initial for y, velocity, our final velocity for y, our dy, our displacement of y, our ay, our acceleration on the y-axis, and our ty, the time. We know that our initial for y is 6.48 because we knew that the final is 0 when the ball stops going up, but then starts to go down a bit later. Our dy, we have no clue about, but we're trying to find that because that is going to represent our height. Our ay is our gravitational constant, 9.8 meters per second squared, or the gravitational pull. We don't want to find out what the ty is, or the time in seconds, is because A, we already solved it, and 2, we don't need it. What we have to do is use another kinematic equation, which is the 1, 2, or 3. Yes, we'll have to use the third kinematic equation for this one. So the formula for the third one is the final velocity squared for y is going to equal the initial velocity for y squared, then add that by 2, then we have to add it by a and d. Well, 2 times a times d. So a as in acceleration and d as in the displacement. So what we're going to do is 0 equals 6.48 squared minus 19.6 dy. dy is in displacement. 19.6 because of 9.8, and we have to multiply that by 2. 9.8 times 2, 9.8 times 2 is 19.6. So that's how we got 19.6 dy. When you square the 6.48, you are going to get around 41.99. When you divide that by 19.6, because that is how you get your dy, you're going to get an answer of dy equals around 2.14 meters. So that is telling us that when the person kicked the soccer ball, if this was the flight plan right here, and this was v for here, then we have dx for the horizontal part, the distance on the horizontal part, then the height of the ball, or the altitude, was 2.14, and that's our dy right here. That is telling us that the ball went up at a max altitude of 2.14 meters until it started to fall back down to the ground. And that is how we solved the first parts of projectile motion. I hope this video has helped you understand projectile motion, part A. Thank you for watching Talk in Your Life's Math Industry. like and subscribe. And what happens if I actually did throw my phone in the cafeteria? Why don't we calculate the max altitude and the flight time before it starts hitting the ground and damaging the camera, like what happened today in this video?